Hello, my name is Dana, and I will talk about some, let's say, more easy options how to access data and metadata in Pangea in the through the programmable interfaces. And these will be using the most common scientific scripting languages, R and Python. So we will start with a package pangaear, which is written for programming language R. So as Uwe already mentioned, pangaear is an open source package, but is not developed by our developers internally in Pangea. It's been developed many years ago externally by a non-profit organization called our OpenSci. So this package was developed by Scott Chamberlain and his team. And yes, so this library offers an interface for data retrieval from Pangea. You can find it standardly at CRAN and GitHub repositories. And that's also where you can find help and documentation, and maybe open an issue and communicate with the maintainers. But we as Pangea are not really actively involved in this process. But still, I would like to give you an overview of this useful tool. So why to use pangaear? Yeah, because it offers us direct data queries and or retrievals via our interface. And it enables automated workflows and data mining, as well as reproducible workflows and a record of data retrieval. So this is very important. Maybe you remember the example what you heard from Katrin yesterday about using the data warehouse, where she stressed that you need to make sure which options you select exactly for your search and for its refinement in order to be able to reproduce that data retrieval. So here it is already included in your script and documented. So that's a very good practice. And pangaear also enables you easier bulk download of data and some basic metadata search and analysis. So I presume some of you are already R users, and so you will be familiar with how to install a library or a package in R. So for that, you use function install package and pangaear as the name of the package. And then before you start working in your session, you need to once load your library with the function library and then the name of the library, pangaear. In the package, there are two basic important functions that we are using for interaction with Pangea, and these are PG search, which is a function for searching in Pangea database in a very similar way Katrin showed yesterday through the browser. In addition, we have some arguments like count and offset. I will tell you later what it is for. And the other function is once you find your data set or data sets, to download data from Pangea. So this function is called pg underscore data, pg data. So I will now jump to my RStudio, which is probably you, our users, are familiar with that. So it's a user interface where you can execute R code. So in this, you have basically 4 panels. The code would be in the upper left panel in my case here. So that's the R code. Below that, there is the console. So where you see what code was executed and what the response was. Then we go to the third panel, where you can see useful things like your maybe your file structure or folder structure, as well as help. So you can here type and look for help for different functions, like your PG data help with examples. And here on the upper panel, you'll see in a moment, there's an overview. For example, you can see an overview of the content and format of your variables. So just a brief introduction, what's happening here, what you're looking at for those of you who are not so familiar with RStudio. And the code in RStudio can be executed line by line with Control R or the whole thing at once. And so I already installed the package pangaear in my environment. So I can comment out these install packages pangaear. But if you do it for the first time, obviously you need to install it. And the next step is loading the pangaear package with command library pangaear. And now it's in my environment active, and I can use the functions that are part of this package. And the first example would be the use of the function PG search. So maybe you recall yesterday we were looking for some projects at the Pangaea web page. So we would have a simple query like we are interested in finding all data sets that are from project CPEAT. And here we are getting 876 hits. And basically the same search can be also reproduced with this line of code. So we are writing the search query in quotation marks. And we can use an additional attribute count. So this is the count how many results we want to get maximum. And we can write the result in a variable. I name it now pages. And what we get as a result is 500 records, which are sorted in a data frame. So it's a data table format in R. So, and the columns are standardized for this function. You get the score, that's the how good the match is. Then you get a DOI of the data set, the size and the size measure. So that could be either data points, or in case of the data set being a collection, you would get an information how many data sets are in this collection. And then citation of the data set. And if it's a supplement to some paper, you will also get an information about that. So that's the result. Now let's have a look at the attribute count. So if you don't use any count at all, you can leave it out, but then you see you will get a maximum of 10. And you can also go up to how much you want, but you will never get more than 500. So 500 is a good number to use for this. And if you want more, you can repeat the search and then add up the search results. So I will show you this with this other command. So first we do the 500. And there are probably more. We already know that there were 876. So we will do this one more. We will add the rest as well. And now we are at 876 results. So that's all we get for this project. So now we have our list of data sets, and we will just select now as an example one of them and see how to use the other function, PG data. So I've copied one of the DOIs from the list of results, and the function PG data is used with the attribute, which is a DOI of the data set we want to get. If we want to get one, it's like this, or we can use a loop or some other function to get more at once. But we'll start with a single data set. And I download it in a variable called single data set. And if you have a look at it, it comes in a structure which is called list. It's a structure with more complicated content than a simple data frame. It has several dimensions, and there you can get lots of metadata related to this data set. You get citation, keywords, references, and coverage, as well as information about events that you heard about yesterday. So that's more geographical and time and methods related content. Then we have a list of parameters. And in the end, very important, we get our data table. See data. And so you can access this part of the list with this formulation and retrieve it, the data itself, the data table itself, by maybe one more line of text, of code. So, and now we get our single data set, only the table without any metadata, but it's something that you might be interested in, most likely, and then you can work further with this. So this was just a little example how you use the PANGAEar. And for more content, I would recommend you as our users to go to the GitHub of PANGAEA and the materials from this or for other community workshops. And then you find, let's say, longer scripts or more examples how to search for data sets, how to filter the search results, and how to get multiple data sets. And some really useful examples how to download multiple binary files like images, netcdf formats, which are part of some of the data sets in PANGAEA. And it was basically all we have time for today for pangaear. I'll move to pangaeapy, which is actually a very similar library or package. It's also open source, and it's been developed by our colleagues in PANGAEA. The package is located also at GitHub, where you can visit the repository and find help and documentation, as well as report issues. And the citation of the pangaeapy is listed here. So basically, what are the advantages or benefits of using pangaeapy? They are exactly the same as for pangaear, only this is obviously for Python users. I would maybe like to underline here one of the points, and I think I would say that pangaeapy has a really good access to metadata and their analysis. So maybe for those of you who are really focusing on metadata, that's perhaps a better option. So as Python users, you would probably be familiar with the command pip install. This is how you install pangaeapy in your working environment. And after that, before you start working in your session, you also need to import the library with import pangaeapy, for example, as pan, or you can also import just individual functions from the library. And as an analog to PG search and PG data, so you will have two basic functions. The one for search is called panquery in pangaeapy, and it has the same attributes like total count and the results. And you use the search query similar way like you do on the website. And then by typing query.result, you will get a data frame with the results in a similar way, and you will see the practical demonstration in a moment. And the equivalent of PG data in pangaear is called panDataset in Python. So that's the function that is used for retrieval of metadata and data of individual data sets. And for example, by typing this pan data set and the DOI is an attribute, you get the data set, and then by typing ds.data, you will get the data frame with the actual content of the data table in the data set. So these are the two essential commands, panquery and pandataset, that we'll be working with. And in the next practical session, we offer you to work alongside with Katrin, who is going to present a Jupyter code. So this code is located in the repository of the community workshop. You can go to GitHub repository, and the Jupyter notebook can be executed directly there via Google Colab. So I'll just show you how to get there. So you go to GitHub repository. Probably you will receive a link in a moment through the chat. And there you navigate to Python and folder PangaeaPy Practical. And there you will find several Jupyter notebooks. So we will be working with PangaeaPy Practical notebook. There is an equivalent notebook with solutions of the so the result of those exercises. But for this demonstration, please use this one, or simply just go down here. And if you want to work with us together in Google Colab, click this link. And so for those of you who are not so familiar with Jupyter Notebook environment, you will see, for example, here on the left side, you will see the table of contents where you can jump to different parts of the code. So the notebook is actually a collection of cells which are either a text or code. The code is those gray bits, and these bits of code can be always executed as a whole. The whole cell is executed at once, and you can do it by clicking this triangle symbol in the cell. So as a first test, before we have a little break, I would ask you, if you want to work alone, to come here. You need to also log in to Google, and then please execute this one cell which says pip install pangaeapy, because that's not installed in your environment yet, and you will need to do it once before you can start working with it. So it might take several minutes, or even seconds, or even minutes if many people do it at once. But let's just do it together before the break, or after or during the break, and then we'll be all set up for the practical part. So for me, it's already working now. And I will now stop the sharing, and there is some room for questions.